everyone, and welcome to today's webinar on surveying public safety networks. My name is Kelly. I am the Solutions Director for the Enterprise here at Ivy Wave, and I am joined by my colleague, Sales Engineering Manager, and our main speaker today, Robin Mitchell. We've got what I think is a pretty exciting webinar lined up today, where Robin is going to walk you through best practices for doing RF surveys for public safety networks, as well as grid testing. As part of this webinar, he's also going to be showing off the powerful and exciting new integration that we've announced between Epic Prism Scanner and Ivy Wave Mobile Survey, which really gives you a seamless and simple way to test your public safety networks, which is what we're going to demo. We're going to try and answer questions as we go throughout the webinar today. So please use the chat box that you see on your screen for GoToWebinar and send them in as you have them. And I'll do my best to interrupt Robin and ask them as we can, okay? Also know that we are recording today's webinar and we will share it with you through an email once this webinar is all wrapped up. And so with that, Robin, I'm gonna hand it over to you to get started. Thanks.
Thanks, Kelly, I appreciate it. Before we dive into our presentation, I just want to show the scanner. And this is the Epic Prism scanner. And just want to show you how small this device is while my camera's still up, because once we start the presentation, I want to turn my camera off. But just to show you the size of the scanner, it has an SMA connector on the end for the antenna, USB connection for power and data connectivity to your device. Right now I have it connected to my laptop. So as we get into the presentation, and I'll share more detail with you about the device, we'll give you an illustration of what the spectrum manner looks like on the device and really get into some fun stuff as well. So with that being stated, we'll dive into our presentation. I'll shut my camera off. All right. So when it comes to surveying and designing reliable public safety networks, quality of service is top of mind. But it's not the only aspect to be concerned about. It's the culmination of multiple tools and processes that create gaps that make this expedition difficult and frustrating for all key stakeholders of the emergency responder radio communication systems, or the ERRCS. System integrators must submit their documentation for the project, and many times those submittals are not meeting the AHJ or the authority having jurisdictions checklist of requirements for the first jaunt. Using disjointed tools creates gaps in survey validation versus verifying design heat map authenticity versus the design quality validation. So there are a lot of challenges just by using disjointed tools and processes. Not to mention or forget to mention the large design documentation. Sometimes these proposals are 11 by 17 or 24 by 36, a hard copy in size, and just submitting that and archiving those documents can be cumbersome, not just to review, but to submit and archive. And then tracking the back and forth of corrections and updates, just a headache just to keep up with all the different changes. And then of course, with all the multiple key stakeholders needing to review and approve the multiple phases of the project. And then you have the challenge of multiple photos being received as-built assurance are documented. And then those change order documentation, revision tracking can be a headache as well. Verifying as-built documentation with photos during the site visit just can be cumbersome with those large documents or floor plans. And then of course, trying to do that with survey data collection, all the DAC testing, grid testing, and capturing all the key performance indicators for that system. That documentation using multiple devices and tools just adds to the effort, the Herculean effort to create this final closeout documentation and archive it for an annual review, and you get to do that all over again. So it is a daunting task to overcome these challenges continuously with these annual reviews.
And hey, Robin, I have a first question here, if I can just interrupt you, sorry. Do you know if the user requires certification or GROL in order for testing to be accepted by the AHJ? Is there any certification required?
Excellent question.
Sure.
So, yeah, as a standard, the majority of the time, the AHJ will require the system integrator to have a GROL certification as well as, well, GROL. That's what that GROL certification is for, verifying that that system integrator is aware of not only the challenges, but has expertise to create the design required to meet those NFPA 1221 regulations and requirements. So yes, not only certification, the GROL certification is required, but other certifications would be preferred. We'll talk about this a little later on, but having IBWave certification to be able to appropriately create accurate designs for that venue. So definitely we want to make sure we're careful to meet those NFP requirements as well as the AHJ requirements. And we'll kind of get into a little more detail about that as we go along. But excellent question.
Thanks, Robin.
Any other questions before we continue?
No, we're good. Thank you.
All right. So that's where our suite of solutions simplifies the public safety survey and design process. Not only being able to utilize a tablet or Android handset in the field in conjunction with the Epic Prism scanner, attaching to, like I showed you earlier, but attaching that to your device with a USB-C cable and being able to seamlessly integrate that in with the public safety desktop solution to provide accurate designs for that ERRCS network. So we mentioned just a moment ago about the need to have certifications in meeting the AHJ requirements. Although each county may have slightly different steps to fulfill fire codes produced by the ICC and the NFPA, and that's the International Code Council and the National Fire Protection Association. Those requirements, code requirements, are related to public safety communications within buildings. It is a responsibility of the AHJ, that's the authority having jurisdiction, to establish these requirements for their local jurisdiction for acceptance for the design, installation, operation, and maintenance for that in-building system. So the building owner, sometimes it could be the AHJ that does the initial sidewalk, but the building owner is responsible for selecting a third-party system integrator to test the ERRCS in-building coverage to determine if a repeater is required, then provide the documentation to the AHJ for the approval of occupancy or notice to proceed. Now, this happens on the initial sidewalk, but of course, on that annual review or inspection I mentioned previously, this step is also required. But that local radio shop specialist reviews and it receives and reviews all the proposals of that ERRCS in the county. Now, some captains, some city captains rather, who oversee the BDA and public safety radio system may require a direct process engagement. So there's a checklist that's usually created on that AHJ's website, documenting the expectations, not only the type of BDA and band frequency associated with that BDA, the type of donor antenna in the band, cable requirements and fire rating, NEMA box enclosure, battery backup, and the list goes on and on. So that checklist can be found on most counties' AHJ's website. Now, even though there's a checklist of requirements, many times the initial submittal gets rejected. As a matter of fact, about 90% of initial submissions get rejected. So the goal is actually to make sure you have all the necessary requirements in place so you can make that first effort maximized and making sure you meet all of those requirements. So when you get to the next step, getting approvals from that AHJ, electrical, fire, and building owner to get the a permit required to proceed to the installation of that in-building system. This installation can't be done until all of those approvals are met. Now, the next challenge is going to be making sure that that system has met all the requirements, but before that installation can, even though the installation is complete, it can't get the final approval until everything is properly documented for that AHJ. So that not only includes component layout, design plan, and a floor plan, but also photos of that equipment and that equipment's location. So whether it's the head-end unit, the repeater, the backup, battery backup, a dedicated enunciator panel, the FACP, or that's the fire alarm control panel, dedicated 20 amp circuits, risers and access doors to all the splitters, donor antenna on the roof, polyphaser, building ground, and lightning ground. All of those have to have photos, and at least a dozen different photos, not only of those components, but the location of those components have to be documented. And then that AHJ comes for that initial site inspection to verify not only what's been submitted, but to also test to see if there's any noise or interference on that public safety network that could cause it to go down. So before that system can even be turned on to be tested, or turned up in some cases to be tested, there has to be verification from the AHJ. And once that system is up, the AHJ will do spot checks on those critical areas. That's making sure that at least 95 dBm in 99% of those critical areas have been tested. And in many cases, the AHJ will provide lower radios to the system integrator for the post-site walk and KPI tests, including the DAC test. And one of the things that is very important, we went too far. One of the things that are very important is the spectrum analyzer that is needed to verify that there's no interference or any signal issues in the area that could cause that system to go down. Has to meet a minimum or as low as neg 120 dBm for the noise floor. So this system integrator not only is required to make sure those requirements are met, but also create a pre-walk test survey versus a post-walk test survey and subsequent heat maps. Now, after this system integrator has done the post-walk survey, capturing all the KPIs, all the metrics required by the NFPA and the AHJ, that test has to be documented and submitted for not only with this current project, but also for annual reviews. So the ERRCS project is ready for final submission, or final inspection rather, after producing the final documentation that we mentioned, which it would include pre and post site walks, as well as heat maps, the survey data, which includes those KPIs, grid tests, as well as the FCC registration document, along with a copy of the system integrator's maintenance contract for, in some cases, a year, up to 3 years or more, depending on the building owner's contract with that system integrator. And then the AHJ partners with the fire department for a joint inspection, not just for fire alarms, but also verifying those coverages that we mentioned earlier. So not just the critical areas with the neg 95 dBm in 99% of the area, but also neg 95 dBm in 90% of general areas. Once those have been met, the BDA passes, the BDA system passes inspection by the AHJ and the fire department. Then the system integrator will get approval acceptance letter and can close out the permit. And of course, this closeout package must be stamped by a signed professional engineer. But all of this documentation, all of this effort has to be fully documented in the closeout package and archived for those annual inspections. Well, that's where our suite of solutions saves time and money for a seamless and complete public safety solution. Our mobile survey solution is an awesome tool to help you document all of the annotations for those photos we mentioned, a laundry list of components that need to be captured and their location, as well as the Epic Prism scanner allows you to capture the necessary P25 data that has to be archived for every floor in that building, including general areas and critical areas. And being able not only to document that, but also archive that up to the cloud where that can be shared with those key stakeholders for a quick review and approvals. And of course, when it comes to the design portion of the venue, being able to create that BDA and accurately create accurate designs and those heat maps, but also component placement throughout the venue, cable routes and donor antenna placement and orientation. All those things also can be illustrated in a 3D map showing not only the equipment placement, but also heat maps. And then of course, generating those detailed reports for that closeout package. Automating that process for all those different reports can be quickly done and make your life a whole lot easier. Then the next phase would be to, once the design has been implemented in the venue, being able to verify or validate that design with the follow-up site walk to capture any as-built documentation changes, perform the grit test, and automatically generate the pass-fail reports needed for the AHJ submission while you're in the field, and validate the performance of that RF coverage for the venue. And then finally, as we mentioned, in the life cycle, not only do you have to capture all this and create a digital twin, you can do that with our IBWave Unity platform, where that digital twin can reside with all that information in a central repository, but also can be, reports can be run to see how much equipment is throughout that county, how many types of BDAs or types of antennas, types of cable, how much is actually deployed, and if there needs to be any adjustments made to say project workflow as these projects are built in your county. So not only documentation, but reports can be run from this, from our IBWave Unity Cloud, as well as maintenance and capturing that digital twin. So when you have to do that site walk again in a year from now, you'll know where all that equipment is located, and you'll have it all documented. So it's easily captured. You're not having to walk around with tons of paper and capturing photos with multiple tools, disjointed tools to make this process work.
Hey, Robin, I have a few questions here coming in. Can we pause and maybe take a couple of them?
Sure.
All right. So the first question here is the neg 95 dBm in 90% of areas. Is that something that's written in code, or is that a suggested KPI?
Sure. So that is part of the NFPA 1221 requirements. And so usually that is part of that AHJ's documentation requirements for, that's listed on their website. So you can definitely find that as part of the checklist of things that need to be submitted in that final closeout package.
Okay, great, thank you. Here's a question on design. Does the software allow the picking of the manufacturer of the BDA, whether it is ADRF or Kumba or any other?
Excellent question. So our solution is agnostic. So regardless of the components being required by the AHJ, because some AHJs are specific not only for the type of BDA, but the manufacturer as well. So we have over 37,000 components in our online database. And so you can use any BDA required by the AHJ for that design.
Great, thanks. And maybe just one more here. Can IBWave show the combined simulation result of DAS antenna coverage and donor site coverage?
Excellent question. So we have a way for you to actually show the in-building coverage from that DAS system, as well as the macro coverage from the outdoor system. So there are multiple ways you can do that. One, you can do that based on survey data captured from around the venue. It could be a ubiquitous signal that has been measured from outside the venue, or you could actually use our REACH solution, which is an outdoor campus solution, to accurately design all the public safety towers in the area that serve those buildings, and even do a design for a greenfield application. I know I don't have that listed in our suite of solutions here, but that's definitely an option to create the most accurate design before that building is even built, and give you that comfort level that your design is the most accurate it can be.
Okay, and just one more, Robin. They're really flying in here, so I need.
Okay.
The Epic scanner, when plugged into the device, that has IVWave mobile survey get automatically recognized once it's plugged in?
Excellent question. So we'll show that in a demo a little later, but just in case we don't get to it, because we have so many questions and I want to make sure we answer all these questions. Yes, when you plug that scanner into your device, you'll turn off the mobile or the tablet's Wi-Fi and put it in airplane mode. So the device will allow the connected scanner to take over the radio capability for the device. So all radio communication, all radio reception is done through the scanner. So once you plug it in, it will see that device as an Ethernet connection. And you'll make sure that is active. But after you do that the first time, you don't have to continue to do that again. So it will see that device as an Ethernet connection, and you're off to the races. You'll be able to use our survey solution to start capturing that data, whether it's the KPIs for a survey or specifically for the grid test.
Okay, perfect. So at this point, I would say let's move on, because I know you're going to get to demoing, which I think will actually start to naturally answer some of the questions coming in. So I would say let's go forward and keep the questions coming. We'll get to them at some point, everyone. Thank you.
Awesome. So as we showed earlier, those AHJ established requirements can be a long, daunting task. But as I showed our life cycle using our suite of solutions, let's see how they fit in. So that initial site survey, capturing the venue's coverage, whether or not a repeater is required or not, can be captured in the field with our survey solution and then saved and uploaded to the cloud for the desktop design. So if there's a required system for that location, you can create that design based on the survey that was captured. And this is a seamless integration. So literally a hyperlink for that venue can be created in the field and then emailed to your designer. They can launch that hyperlink and begin designing for that project quickly before the integrator that did the capture in the field even gets back to the office. The survey design process can begin. And then after the project is complete, the design is complete, then the installation is complete, verifying that design is according to the requirements, using, once again, our survey application with the scanner attached. You can not only take photos, video, voice notes, and text notes, verifying any changes, as-built changes, as well as revision changes as that project had been deployed. So you can actually see the progress of that venue and the changes made along the way within that same project. So the beautiful thing about that is being able to archive that going forward. And the Unity Cloud, you'll be able to make sure as changes happen to the building within that year inspection due date, you'll be able to document that again and show that those changes have been done and verify whether or not that venue is still meeting those NFPA 1221 requirements for critical areas and general areas. So let's dig a little deeper. I know we have a lot of questions about the scanner, and let's just briefly look at some of the scanner capabilities. As I mentioned, it does connect to that tablet or, well, it's actually an Android device, but it could be a tablet or a handset, but it will connect it will connect through a USB-C cable for power and data connectivity. And this is used for your survey and grid tests. And as you collect data with the survey solution, you're not only documenting the data, but you can capture annotations required for those pictures that need to be submitted to the AHJ. And then finally creating that report for the pass and fail grid test that needs to be submitted along with our closeout package. But you can actually create a PDF report in the field after creating that grid test. The AHJ can actually verify and sign off on right there on the tablet. So it really makes that integration super convenient when you don't have to carry around all of those papers of that, floor plan layout, and photos of all the documentation, track where everything's located. Now the scanner is, like I mentioned earlier, is connected with a SMA antenna that actually comes with an antenna, or you can use, I know a lot of times you want to use that same SMA antenna that the radios for that AHJ are using. So obviously you can change those out with that SMA connector. But just want to point out the technologies that are capable in that scanner. Initially, we were launching it with P25, but we have LTE and 5G coming very soon. And I mentioned quite a bit those KPIs, or key performance indicators, that are captured by that scanner include band, channel, RSSI, bit error rate, and SINR. And so that frequency range of that scanner is very robust, from 70 megahertz up to 6 gigahertz, and it actually weighs less than a bottle of water. It's super light and easy to use, and there's no device routing to connect to your tablet or your phone. And it is a software-driven radio. So calibration is quick and simple. Upgrades are just a software license update. So you're actually able to take advantage of any new technology that comes down the pipe. As a matter of fact, that software-defined radio is already incorporated with multiple protocols associated with CBRS, Wi-Fi, Zigbee, and 5G. But initially, we have integrated our survey solution with P25. And as I mentioned, coming down the pipe very soon, LTE and 5G. But this definitely takes care of problems that are facing the public safety network, those ERCS system integrators, and providing the most accurate design based on field captured data, even in building as well as greenfield scenarios. And the cool thing is this scanner has actually been used with a Whisper drone to capture unique scenarios in greenfield opportunities. But because the scanner is software-defined radio, it has a robust protocols available to it. Whatever that next technology is coming through IoT or within that 70 megahertz to 60 gigahertz spectrum, the device is capable of meeting those needs. So let me just show you very quickly spectrum analyzer from that scanner. Actually, I have it plugged into my laptop now, so you can see I'm capturing 700 megahertz with a 10 megahertz span, but you can actually place your cursor, or on the tablet you would use, just tap on the screen and you can see where you can pin different peaks, or if you want to capture a span, you can mark it, or as you can see, I can see all the different frequencies that have been captured. You can delete those individually. We can do some other, quickly change to a different frequency if we want it. Oops, let's try it again. And see, let's just do this. Let's grab back here, and we can actually zoom in to that span. Of course, we give you some other cool things that you can see with your spectrum analyzer. You can set your reference level, your dB per division. We can give you an opportunity to change the theme. So if you don't like that color theme, you need to change the lighting because of the area you're actually testing in, whether lighting is bad or you need some lighting themes to help with the brightness of the room. You have multiple themes rather to work through. And this is my favorite. As I mentioned, you can set traces. You saw we set markers, and it's easily to update the software to the device by connecting and a license to, in this case, I'm connected to a laptop. You can download that update to make sure you're capturing your spectrum analyzer needs. So let's switch back over. So what I'd like to do, because the device needs to be connected to your Android device and it takes over the radio capabilities, I'm going to show you a video of what the data capture looks like when you're doing a survey. All right, so when you open up your project on the tablet, you'll select the floor plan and you'll start by selecting the survey option. And as I mentioned earlier, you do need to turn off the Wi-Fi and put the device in airplane mode to make sure to allow that scanner to take over the radio connection for that device. And you see once the device sees the scanner, it sees it's connected to a USB device, and you should get a pop-up option to connect it as an Ethernet device. So you'll turn that option on, and that completes the connection between the device and your scanner, whether it's a tablet or a phone. And now once you're in back in our survey solution, you'll click on Capturing Survey, and you'll see that you can collect P25. We'll use any P25 frequency. You'll type that in up to, I believe, 5 decimal points, as well as you can use multiple frequencies. So not just the one, you can capture as many frequencies as needed. You'll see that you'll connect to the scanner, or you could actually use the device for its own radio purposes, but we'll just keep it on the scanner for now. And then we'll click Create in the top right corner, and you're off to the races. So this is for that initial site survey to capture the spectrum, and of course you use your spectrum analyzer to verify what frequencies are available in that building, and you'll start capturing that data by tapping on the floor plan. We'll call those waypoints to show the way you were walking in the venue. And you'll notice after each tap on the screen, the initial tap is black, and we'll speed this up. But the initial tap is black, but once the scan is complete, the waypoint turns green to give you confidence that you've actually captured a complete scan at that location as you continue to move through the venue. Now, this is your initial site survey, and so once you've completed that site survey, clicking the red check mark in the top right corner completes that survey, and you can see the RSSI captured for P25 in the venue. It's actually using an interpolation feature that shows the propagation of what that potential coverage would look like in other areas of the building that you actually did not walk. So that's a really neat feature. You can see with the legend at the top, the percentages of that survey data captured. If you tap on one of the waypoints, you'll see not only the frequency that was captured, but also the signal strength, the SINAR, and other KPIs that we mentioned. And if you have multiple frequencies that were captured at that location, as we mentioned, you can create a list of frequencies. You'll see that information also associated on the graph. So as we look at our, as I mentioned, the interpolation, you can turn that off and on, but there are other KPIs that you can view from your site survey, the RSSI, SINAR, and of course, throughput wasn't captured in this scenario, but this gives you an idea of what that initial site survey will look like for your venue. All right, so when it comes to survey, and I'm not sure how much time we'll have before it, so we can make sure we have questions, but I'll quickly talk about the grid test and the process that goes along with capturing the grid test we mentioned earlier. And I want to, although I have a video, but this is, we'll see if we can shorten this for our the time we have remaining. Let me swim back over to my I'm not getting my video to play for me. So let's see if we can close out of my scanner and see if I can get back to that video now. Looks like I'm not able to get back to my video. So I'll just speak to the process in capturing that, the grid test. On that floor plan that we showed earlier, you can actually create a, I'm going to attempt. It's always funny to me when technical people have technical difficulty, and I'm going to attempt to actually do this on my device. Even though I can't show you the grid test, I'm at least attempt to show you what that grid test would look like. So we'll just grab the survey tool. I'll just grab one of my projects. Let's see. You see, we actually have you would normally capture a floor plan. There are multiple ways you can capture a floor plan. Let me just mention that. Ideally, you would want to download that project from the desktop with all the details of the design. It would be great to have that AutoCAD drawing of the floor plan and be able to incorporate that initially and give start an initial design of what that building system will look like. But in cases where you can't pull that project in from the server and you need to capture it from the field, you can actually create a new project. And we give you multiple ways to do that. You can capture it from an outdoor plan using a Bing aerial map. You can pull it in from a picture that's saved on the device. You could also use floor plans, as I mentioned, and this is for the outdoor portion, but use a floor plan to take a picture of, say, of a fire escape route, an elevator or a common area, or you can select a picture that's already captured, or you can manually create one. But let's just swing back. I'll just grab, I've got a picture here of a floor plan. So I've got a floor plan here. I'm going to use that floor plan. I'm going to set my scale. And we'll set that scale to 50 feet. And then from the grid test, I'm going to add a grid test. Now the idea is, because you're wanting to do this grid test based on the AHJ requirements and in association with the NFP 1221, you'll notice down at the bottom, I'm getting a note that says my grid size needs to be larger, at minimum 20 by 20 feet, no larger than 80. So right now my grid size is too small, but once I reach that requirement, that note goes away. And so I can now expand the grid, and let me expand that some more. So I have my grid expanded, and I'll zoom out just a little bit. All right, I'm done with that. And let's see if I can, there we go. So each cell allows you to capture the signal or the KPIs from that associated scanner that's attached. Now the challenge I have now, I don't actually have the scanner attached to my device, because if it was, we wouldn't be able to see my screen. Because the device has to be in airplane mode and the Wi-Fi connection has to be turned off. And so if you click on that location, because I don't actually have the scanner connected, it's showing that it failed. But you would take samples, and as I click on this red icon, it would take samples based on the scanner's data collection through the frequencies that we set up in the initial settings, and you would see the sample count go up, and it will give you an average. You would see the frequency that's collected. You'll see the power, the power and the DAC score associated with that device. You can also set up different KPIs that can be captured, not just the power and the DAC, but also FER and bit error rate. But of course, at this location, it failed. But if it did meet those requirements, minimum requirements, this would show pass. So let me back out of this, and let me see if I can get see if I can get that video to play for at least for the report, because we have just a few minutes. Any questions while I try to pull up that other video, Kelly?
Yeah, so a lot of questions around battery life, Robin. So maybe you can talk a little about how the device is powered and what a typical, if it would last a session for our survey, or yeah, a lot of questions.
Okay, wonderful. So because the scanner gets its power from the USB-C connection to the device, it is powered by that device's battery life. So you can use a USB-C battery extender. So you can actually, which is really cool. So as long as that extended battery will last, you can get hours upon hours of use during that site walk on one initial site walk. So definitely takes care of the pain points of running out of juice while you're doing the sidewalk.
Yeah, thank you. Also, a lot of questions here around the DAC score. So can you talk a little about how it is calculated? Is it based on the SINR and BER, or is it just a text field that you enter your own DAC score? Is it automatic?
Excellent question. So the DAC score is automatically calculated based on the RSSI, bit error rate, and SINR captured during that sidewalk. Of course, we know the bit error rate and SINR are ratios, but there are metrics required to meet that DAC score, and those are automatically calculated for you in the background. So you don't have to walk around and continually ask, can you hear me now? How do I sound? Is this clear? Are we meeting those minimum requirements for, 3.5 DAC score during our conversation with the AHJ?
Great. Do we have time for more? Is your video working there?
I think I could get my report video to work, and I know I'm going to run into an issue, but we'll see if we can get it to play for us.
Great.
All right. So with the grid test, when it's complete, you'll select those 3 buttons in the top right corner to run that report. And you can run a report for the survey or the grid test, but we'll just do this for the grid test. And when you click run, it will start automatically creating a PDF. Of course, you can give the PDF whatever name you choose, but it will give you the report of whether or not that building passed or failed based on the average scores, as you see there on the KPIs for coverage, power, SINR, and the DAC score, not only in the general areas, but also in the critical areas. And you'll see each floor, if the building has multiple floors, you'll see not only the square footage, but also whether or not you passed or failed for each section, general area and critical area of the floor. So it really makes it easy for you, as well as capturing the bands or the frequencies that you selected. So that's on the first page of the report. The next page of the report shows the grid layout that I tried to demonstrate earlier, but it shows you all the green check marks are where you passed, and the red X shows where you failed. But if the overall floor pass, you'll get a pass, and those black triangle exclamation mark shows the critical areas. But you'll also see, and then that video dies on me, but you'll also see that each individual report has a detailed list of the sales that were captured and whether or not those sales passed or failed. And I apologize for my clumsy video operation here, but definitely the survey process will be a whole lot smoother than my video replays there. But the idea is to have a seamless solution for all the processes through your public safety design and validation. Now, we do have some courses available for training. We have in-class and virtual. Of course, the in-class will be virtual at this time, but we do have a way for you to access that on our website for the certification programs, as well as on our community, our IB Wave community, our Wave Runner community, for training individual modules, standalone courses, and also free courses. And we actually have a IB Wave public safety certification class specifically for public safety. Any more questions, Kelly? I know we kind of ran through that in very quickly there, but any more questions for us?
I got a lot of questions here, Robin, which is a good sign, right? But let me just try to pull one out here. There's questions around if it just does the downlink or also the uplink. Let's start with that. Can you test
Sure.
uplink and downlink, or is it just?
Sure. So the frequency bands are based on the spectrum analyzer. So whatever frequencies you place in the spectrum analyzer will be captured on the device. So it is limited to the frequencies that you enter into the device during your site walk for both the survey and the grid test.
Okay. And do you know if it's possible to share how the DAC is calculated? It sounds like many AHJs want to understand the calculation or how it was calculated. Is there a way for people to share that? Yeah.
I'm sure that there's, I've seen it documented in many different locations of how that DAC score is captured. Unfortunately, I don't have that equation with me or able to share that with you, but definitely I will have to look into a way to see if we can share that, Kelly. I don't know if you have any proprietary requirements there.
Right. Okay, we can take a look into that one. So the scanner collection data, RSSI, can that be integrated into the IBWave design heat maps?
Absolutely. So definitely you can seamlessly share that sidewalk data with the desktop and overlay the site survey that was captured with the heat maps from the design for the placement of those antennas and coverage antennas inside the building.
Okay. And can you go back a slide, Robin? Looks like some people are looking to write down the training information there, so give them a bit of time to do that. Let's see. Will the design program be able to determine if duplex filters will be required based on the input downlink/uplink frequency and bandwidth requirements? So
because you actually have the capability of attaching an SMA connector to the scanner, you can capture what that network is, what that system is seeing, and you'll be able to make that assessment in the field. So, but of course, you can design those duplex filters in your design plan based on the requirements for that venue's coverage. So you have a way to not only design it but validate it in the field.
Okay, great. And maybe just one last question here because we're a bit over time. Can you break out reports into each frequency when the data is collected for multiple?
Wow, that is a great question. So because you're actually capture each frequency, you can capture multiple frequencies during your site walk. During the site, once you upload that to the desktop, you can select frequencies individually. And of course, as I mentioned, if you tap on those waypoints within the survey solution itself, the mobile survey, you can see the different frequencies and the KPIs associated. But yes, you can individually show those frequencies in the design plan.
Okay, great. So I think at this point we'll wrap up the webinar. We have a lot of questions here. So what we're going to do is take them back and we will try to reach out and get each of your questions answered. I want to thank everyone here for joining us and asking so many questions. It's great to see the participation and the interaction and the interest from everyone. So really appreciate you guys taking the time. We will send out a recording. We can send out a PDF of the deck. I've got a few questions around that. You can head to our website. There's more information if you go under our public safety solutions under the products menu. We have a data sheet and we can send that out in the email as well. It'll give you more information. So big thanks for joining us and big thanks to you, Robin, for doing the webinar. Appreciate it, you taking the time as well. Thanks everyone and have a great day.